Alright, so basically, the degree of the polynomial tells you how many solutions that polynomial has. Some of them are gonna be real numbers. Like for example, if this polynomial had 4 x-intercepts, it had 4 real solutions. If it had 2 x-intercepts, it had 2 real solutions and 2 complex solutions. If this has no x-intercepts, then it has 4 what? None of them are real.
Complex.
4 complex solutions. So we're just getting to the very tip of learning how to solve a polynomial equation. All right, let's start out right here. Let's go back to elementary. Would you guys find the greatest common factor of 36, 48, and 72? Find the largest number that will divide into all of them evenly. Does anybody know what it is?
Yes.
What is it?
12.
Bigger than that.
13.
12?
Oh.
Okay. Do you guys remember, and you probably did this, I'm just going to go the old-fashioned way. You probably did a factor tree. Does this look familiar?
Yeah.
And you said, okay, that's 2 squared times 3 squared. Do you remember that?
Yes.
Okay. There's another way to do prime factorization. It's like this. Yeah. It's beautiful the way that it works out and gives you the prime factorization in order. Okay. So what is the smallest prime number? And don't say 1.
2.
And don't say 0. What did you say?
2.
2. 2 is the prime number is defined this way. A number greater than 1, so that eliminates 1, right? A number greater than 1 that has only 2 factors, 1 and itself. So 2 is the smallest prime number. What's the next prime number?
2.
And the next one?
5.
And the next one?
7.
So y'all have an idea? Alright. So are all the prime numbers odd?
No. 22.
2's not either. Alright, so 2 will go into 36 18 times. What's the smallest prime number that'll go into 18?
2.
Still even, isn't it? 2. And it'll go 9 times. Now 2 won't go into 9, so the smallest prime number that'll go into 9 is 3. And it'll go 3 times. When I end up with a prime number, my prime factorization is finished. And so there you go. Okay? So let's try 48. You do it with me. What's the smallest prime number that'll go into 48? It's even. 2. It'll go 24 times. What's the smallest prime number into 24? 2. It'll go 12 times. Smallest prime number into 12?
2.
2. It'll go 6 times. Smallest prime number into 6?
2.
2. And it'll go 3 times, which is a prime number. So this prime factorization of 48 is 2 to the 1, 2, 3, 4th power times 3. Alright, I'm going to let you go on your own. Try 72. Alright, so I've got basically 8 times 9, which is 72. Alright, to find the greatest common factor. What factors are common to 36, 48, and 72? Well, all of them have 2's and 3's. Alright, now what is the lowest, smallest exponent of 2 that you see in those prime factorizations? Is it 2? Is it 3? Is it 4? 2 is the smallest, right? What's the smallest exponent of 3? 1. What's 2 squared? What's 4 times 3? That's the no-nonsense way of finding the greatest common factor. If you do their prime factorizations, and you take the smallest, or every common factor for all of them, and then take the smallest exponent of each one, you got it without having to think. So that gets you past 6. You know, you go all the way and figure out that it's 12. Alright, let's look at these examples. Let's start doing some algebra. Now, greatest common factors in algebra can be numbers and variables, or either or. It could have just a number, it could have just a variable, or it could have both. Look at 5am and 5an. What is the greatest common factor number? 5. What's the greatest common factor variable?
8.
8. So they both have a common factor of 8. Now factoring, guys, is division. I just told you when we were multiplying polynomials that factoring was the reverse of that, right? We were backing up and going backwards. So what's the opposite of multiplication? Division. All right, so what I'm going to do is I'm going to take the greatest common factor and divide it into both of these factors. What is left is going to go inside the parentheses. Raise your hand if you've ever factored out greatest common factors. So this is new. Did you do it? Have you done it?
We did it on math team last year.
Did it on math team last year? Okay. I'd say for most of us this is brand new. So don't feel like you can't ask a question. I know y'all are smart, but everybody's going to have a question when you start something totally new. So please ask, okay? So factoring is division. I've got my greatest common factor. I don't need a common factor. I need the greatest common factor out here. That's important for it to be totally or completely factored. All right, so 5 divided by 5 is 1. A divided by A is A. That leaves me with an M. Negative divided by a positive is a negative. The 5's and the A's cancel, and I've got an N left. This is completely factored. Now, yesterday, this would have been our problem, and that would have been our answer. But today, we're in reverse, right? We're factoring. We're learning, remember, if we had that big long polynomial, we'd look to see first if I got a greatest common factor I could factor out. We're going to learn the rules of factoring, and we're going to learn them in order. No matter what kind of problem we have from today to the end of chapter 9, no matter what all we learn, you first look for a greatest common factor. Let that be the first thing that hits your brain, okay? Have I got a greatest common factor? Because if I do, I must do that in order, so I must do it first. All right, look at this. This is a cubic binomial, because I'm going with the variable that comes first alphabetically. All right, here's my question. Is there a greatest common factor number?
No.
3 and 5 are both prime. Is there a common variable? Okay, then this is not factorable. But we don't say it has no solution. We call it, like we do all things that cannot be factored, we call it prime. Prime numbers only have one in themselves as factors, all right? So prime means not factorable. All right, let's look at this next example. Remember, you're not having to write it down. It's just in your packet, so flip the page. Now I have a quartic. What does that mean? C is to the fourth power. I have a quartic what? Trinomial. All right, so looking at the numbers 2, 4, and 6, what is the greatest common factor for all the numbers? 2. And looking at all the variables, what's common? C. And the lowest exponent of all them is 2. So that's my greatest common factor. And I'm going to divide each of these terms by that 2c squared. All right, the 2's cancel. Now, what's the rule for dividing with exponents? If I divide the bases, I subtract the exponents. So c to the 4th divided by c squared is c squared. Negative 4 divided by positive 2 is negative 2. C to the 3rd divided by c squared. Keep the base, subtract the exponents. That's going to give me a 1 right here, which I can write or not. Positive 6 divided by 2 is 3. And c squared divided by c squared. That's dividing something by itself. That's going to be a c to the 0 power, which is 1. And 3 times 1 is 3. Now, when we learn other types of factoring, we would look to see, will that factor again? Because not just one rule of factoring applies to every problem. Sometimes we'll factor a problem 2 or 3 different methods in the same problem, but we don't know any of that yet. So we're just going to say, oh, that's it right there. Which I don't believe that one will factor again anyway, but just learn to keep looking. Keep looking. Well, that keep on factoring. Every time we learn a method, see if it applies to that problem. But we got to do it in order, okay? And I'm giving you the order as we go, so I'm telling you today that number 1, always look to see if there's a greatest common factor. All right, would you guys try these 3 problems, and then we'll do them for dollars. That's good. Very good. Good job. Does anybody have a question? Now, it's possible that you just have a number factor or you just have a variable. We didn't have any of these, but that's possible, so don't let that throw you off. Okay, let's keep on going. All right, let's look at this one. Looking at the numbers, what's the greatest common factor? 4. Okay. Looking at the variables, what's the greatest common factor?
Wait,
Y to the
third.
third.
Yeah.
All right, so I've got a 4y to the third. That's common. All right, now here's the question, and here's where everybody will mess up sometimes. What's anything divided by itself? Yes, it's such a simple thing. But people will cross them out and like leave it blank, like leave nothing there, like put just negative 4y inside here. But anything divided by itself is 1. And negative 16 divided by 4 is the negative 4, and y to the 4th divided by y to the third. There's my negative 4y I was talking about. But if you started with a binomial, in the parentheses you're still going to have a binomial. Does that make sense? Because what would give me this back? You know, you can check all your answers. All you got to do is do the distributive property. And what would you get back? The problem.
On the last page, there was one, that very first problem, they're divided by itself.
Yeah, I didn't even look at that. I'm glad you mentioned that. I did not even check. What should this be? +1. Thank you so much for mentioning that, because I never looked. It's my fault. All right, does anybody have a question? So anything divided by itself is 1. I did not even see that. All right, let's look at this one. What is the greatest common factor of number? Good. Variable. P. This one has a Q, but nothing else does. And so we're going to factor out a 3P. All right, so 6 divided by 3 is 2, and the P's cancel, because that'll be P to the 0 power, which is 1, right? Multiply 1 times 2, get 2. 15 divided by 3 is 5. P squared divided by P to the first is P. Negative 9 divided by 3 is negative 3. The P's cancel, but the Q is still there. And again, if I want to check my work, look for 2 things. Look inside the parentheses. Is there a greatest common factor still left in there? 2, 5P, negative 3Q. Is there a greatest common factor still left in there? Now that could mess you up. You always need to check that. And then you can do the distributive property and get back to what you have. But it's possible to do it with the distributive property, get back what you had, but still have factored out the wrong thing if this contains any common factor still left in it. Okay, by that I mean, what if I have 12x squared minus 2x? All right. Let's say I just see the 2. That's all I see. And I factor a 2 out of there. I'm doing this wrong. Doing this incorrectly. So factor out a 2, I'd get a 6x squared. I'm sorry, I wouldn't need it. Yeah, I would. 6x squared minus x. Okay. If I do the distributive property, I'd get back to here. But what do you see still left in there? X. What should I factor out? A 2x. Should have factored out 2x. So be really careful because that's not correct. Alright, let's do these two. Why don't you try them? You've done them.
So you're doing this, can you just do it?
Just do variable, yeah. On that one, 17's prime, so you're just going to do x and y.
Okay.
X
Regular
to the
regular.
first and y to the first, yep.
Now, it's possible, like on the second one, that you don't have a number. It's a variable. That's right. Can you do the second one? One at the try. When you look at number 33, there are no numbers that are going to 17 other than one in itself. So all we can pull out is like common variables. So we have an x and a y, and both to the first power. That's all we can do. If anything will factor out other than one, then it's not prime. Okay, but if only one would be the only common factor. Y'all remember doing prime factorization of like 17? And only one would go into it, right? And so you'd say, oh, it's a prime number. Well, the same thing's true with polynomials. If only one will go into them, then it's prime. But in this case, x and y are the common factors. So that's right. Now put your x, y right here. Yeah, that's good. And then you'll have minus 8xy plus 17 y squared, because the x is canceled. What about that one, guys? That one tough?
Just a little.
Yes.
I didn't know we did it first.
Yeah, that was tough.
Kinda got it.
So it's possible just to have a number, it's possible just to have variable or variables, right? Or a lot of them we work at both. Alright, here's our assignment. We got about 10 minutes, so let's work on it.